Hello everybody, welcome back. Actually no, welcome to our first video on AeroDataSpace. In this channel is going to be the marvelous topics, math and science. These topics are probably the most fascinating things we have to offer. It helps us in our world so much, and it can be used for such things. So this channel is mainly about math and science, those type of topics. So I'm just going to be doing tutorial videos. This can be used for educational purposes, or it can just be used to be satisfied by these topics. So now, I'm actually an 11-year-old who's in 6th grade, and so, as you know, I might not have the biggest experience to these topics. However, I'm going to put everything I know, and I'm going to make it as true as can be. So, without further ado, let's get into this topic. So now today's topic, by looking at the title, is going to be called conversion of energy. This is rather a fascinating topic. So now, before we get into this, things we have to know. We need to know some equations, right? So let's just say we're going to be calculating potential energy, kinetic energy, and velocity. So potential energy, we'll call it that, equals to mgh. Mass, gravitational force, and height. Now, kinetic energy, we'll be doing the second way. 1/2 mv squared, or in other words, is PE1 minus P. Sorry, that didn't look. Sorry, that does not look like a P. PE. Sorry, where did it go? It's my bad. Equals PE1 minus PE2. Initial and the point we're on, which I'll explain later. So now, knowing these equations. Actually, I'm sorry, there's one more. The important one. Pretty important. So what roller coaster engineers use to... KE. That's one variable. That looks like two variables. But this is basically one variable. Alright? So I'll show you another example. 2 times kinetic energy over mass. So if you're thinking this is two variables, it's not. That's just the way I put it. In other words, that could be basically, and we'll call kinetic energy K over mass. So K equals KE, and then M equals mass. Right? Easy enough. So now, here's what you have to do. So now, we are calculating in kilograms, meters per second. That's what velocity is right here. Okay? And our unit is going to be joules. Alright? So now, let's get really into this. After knowing these equations, I can give you a quick explanation of these. So P equals mgh. M is mass and h is height. Now G is basically gravitational force. So as 1g, it's 9.8 meters per second, right? Meters per second. So that's 9.8. So that would be 9.8. So that means G equals 9.8. So that basically means that P, sorry, my bad. I'm not really familiar with this. So that means that PE, so that means PE basically technically equals M 9.8 H, right? That's basically our thing. I'll explain mass in height later in the video. So let's get into this. Let's just say we have a roller coaster. It first starts off here, goes up the chain lift. After that, drops down, rises back up into a smaller hill, back down, and then just straight. So now, the reason why we're making a roller coaster like that is to calculate the height. So we're going to be making potential energy, kinetic energy, and velocity in these type of circumstances, right? So now I'm going to make up heights. I'm making up heights. So now, let's say from here to here, the top of the chain lift, it's going to be I'm thinking maybe actually there's something really simple to be honest. So let's just do 1.2 meters just for the fact of it. Really small, I know. Ridiculously small. Alright, no biggie. Say from here to here, 0.5 meters. Here to here, this is 0 meters. This is also 0 meters. Sorry. Actually, let me change something up. Let's say this is 0.1 meters. No, 0.5. Right? Oh, I'm so, 0.5. We're right. Let's say this is. Actually, no, I'm sorry, we're wrong. 0.5 meters. This is 0.3. That's 0.3 meters. And yeah. So now, if you can't understand this, I'll get into it later. This is point A, B, C, and D. So now let's make a quick table. A, B, C, D. All right. So now, let's take a look at A's height. A's height is 1.2. B's height is 0.3 meters, of course. This is 0 meters. And this is also. What's it? I might have missed one. Actually, this one doesn't really count, so it's fine. Keep going. C is 0.5 meters. And then D is 0 meters. I didn't include this because this is going to be equal to that. Because there's 0 meters, same height, basic thing. So don't mind that. Now, not knowing the height, let's calculate. That did not look good. Let me undo that. Let's calculate potential energy. Potential energy, pretty cool thing. A pretty cool thing. So, the way we're going to do potential energy is by using the MGH formula, right? Okay, sorry about that. I just had to do, because I had to grab my calculator. Has been doing some math. So, let's take a look at MGH. So, before we need to know our M and H. So now, let's say the rider, including cart, say, I don't know, for the sake of time, 100 kilograms. Right? So now the height. Since we're doing A, the height is 1.2 meters, right? Right, correct? Good. So now these are we also know that G equals 9.8. As this is also just meters per second. Great. So now let's take a look here. So now let's plug these in. So we'll turn into mass is 100 kilograms, so 100 times 9.8 times 1.2. This can just be easily simplified just using basic math. 980, right? Just check my math. Yep, 980 times 1.2. This then equals 80 times 1.2. Sorry, 980 times 1.2 equals 1176. Right? 1176. This is also in joules, so we just put J. So 100, so 17. Now remember, this is our initial mass, right? For our kinetic energy formula, right here. P initial, P1 minus P2. This is initial. This is the potential energy at that certain point. And if we're talking about initial, that means the top, which is right here, the highest point of the roller coaster going down. Correct? Correct. So this shows how much kinetic energy can be released with that amount of potential energy, right? Good. So now, let's do B, right? B is 0.3. 0.3, let's just plug these in real quick. That's 1.2. Whoa. Oh, I'm sorry. One second. I messed up. Do not do that. I rushed a little bit. So remember, we're taking this and putting it in. So G will go next. 9.8, and then time is the height. The only thing that will change in your formula is just right here. This will not change. Once you identify these variables, this will never change. Once you identify, it could change if you have 2 G's, 3 G's, 4 G's, but we're currently in just 1 G. This can change if your mass changes. This doesn't really change if we're talking about 1 G, so yeah. This can be easily simplified into, 980, that's like we did, times 0.3, 980 times 0.3 equals 294. That means B is 294 joules. Easy enough. Next, C is 0.5 meters. So this is really basic, so I'm just going to run through this. You guys can feel free to follow along, whatever makes this learning fun and enjoyable. We'll just do 980, considering we know that 0.5. And just doing math, that would equal 490. Check with the calculator. Yippers. 490 joules. Now that is 490 joules. And then 0 meters, knowing that we're multiplying something with the height of 0, that would automatically turn to 0 joules. So you have no potential energy in that type of circumstance. So, put a line here. Now let's do kinetic energy. I'm going to continue this graph. So let's do A, B, C, D. Easy enough. Let's put the height real quick. No decimals, right? 0. Check. Yep, good. So no units. Considering we can simply just put M for meters, right? So now let's do kinetic energy. So let's do A. A equals, let's see our initial 1176, right? 1176. 1176 minus 1176. Why am I doing this? PE1. This is initial mass. This is initial amount of joules for the height. And if you look at our graph right here, that's height, and that's A. And A is that. Now we're doing PEE2, which is basically the same thing because we're at the same height and the toss point of the roller coaster. That means equals 0. 0 kinetic energy, right? Seems reasonable. So then we can just put this in the table. 0 G. Well, not J. If I say G, I'm sorry. J. 0 J. 0 joules. So now, let's do the next one. So now let's do B just to spice things up. Knowing that that's 176. So now, considering that we have covered for PE1, right? We have to do minus PE2, right? Now, let's take a look at B. B is 294G. J. 294J. Because this stands for the toss point of the roller coaster, A, and which was released. That's the amount. That's the total amount of potential energy, the initial potential energy being exerted to the roller coaster. The initial potential energy being exerted to kinetic energy being transferred to the cart, right? So now, considering that this is PE1, now this is the potential energy we have at this location, because as you know, we still have height. So that means there will still be potential energy that can still be transferred. If we're stationary, we have potential energy because we can exert the energy into this type of height. We can exert that energy into that 0.3 meters we have. So that means we do have potential energy in this location, right? And doing the math equals 882 joules. And I think you guys might be able to catch this, but there's something really fascinating. Well, not really, but something that proves that we are right. Next, 0.5. C equals 1176. That's initial, right? 1176 minus our what we have for C. Now, C, if you look to our math, 490. 490 equals. So now I'm not going to explain this to you guys as much because I hope you'll understand. If you do not, go back to the video and take a look. If you're so confused, feel free to leave a comment and I will touch back to you. 686 joules, looking good. And then 0 meters, this will be simple. 1176 because we have 0 just for potential energy. Now, we haven't already knew. If we add kinetic energy plus potential energy, we would always get that initial. We will always get 1176 joules because that potential energy is being subtracted from the initial energy because that's how much kinetic energy we have transferred through the cart, right? Got it. So now, here comes maybe a little tricky part. So we're only going to do 2 because these formulas do take a little while, right? We're only going to do 2. This one, no, this one would be definitely different. This one would be, yeah. Actually, no, wait. Velocity would have to equal 0 because we have 0 joules, right? So now we're going to do these 2. B and C. So let's do 0.3 and 0.5. Correct? So now 0.3 and 0.5. I'm just taking a look at the joules. 888.882 joules. And then C, 686 joules. So now, let's start with B. This is B, if you haven't already known. And this is C. B equals, let's take a look. B equals that. So then if you plug this in to their formula, 2. And then this is kinetic energy. This is how much kinetic energy we have at 0.3 meters, right? No, it's potential energy or kinetic energy? It's kinetic energy. Yep, you're right. That's right. So kinetic energy, right? We have 888.2 joules. And then this is over mass, which to be clarified is 100. Correct? Correct. So now all we have to do now is solve this equation. So 882 times 2 is that 1764 over 100, which then simply equals 176.4. Square root of that. These will never ever come out of the same. So it's basically about 13.2 meters per second with destination mass. So now our velocity for B equals 13.2 meters per second. That is B, which is 0.3 meters, correct? Now in this equation, we can calculate the meters per second for any given height with the mass and the kinetic energy. Correct? So now let's just do this for C real quick. 0.5. That's our height. If you plug this into our equation, and then our kinetic energy for C is 686. 686 joules, and then over 100. Correct? Correct. 686 times 2 is equal to simply this. I can't see my calculator. 137.2 over 100, which is then simplified to 137.2. 137.2 square root that 100 equals, which is about 11.7. 11.7 meters per second. Pretty fascinating, eh? Now, we can know this is true if you look at our table. Our thingy right here. C is higher than B. 0.5, 0.3. We'll have less speed once we reach that point than rather here. Correct? Right. That means, and if you look at if you look here, B is 13.2 meters per second, while C, on the other hand, is 11.7 meters per second. And since it's a 0.2, the difference ain't going to be big. So, hopefully that helped. This is all ridiculously fascinating. This is conversion of energy, and this is AeroDataSpace.